everyone, this is Pauline Angel, URK20CS1015 from the Department of Computer Science and Engineering, KARUNYA. In this video, I am going to explain you the implementation of a doubly linked list in data structures and algorithms using Python. So let's get started. So our aim is to implement a doubly linked list with insertion, deletion, search, forward traversal and reverse traversal operations. So let's see the code here. So I have written the code by creating a class called node, which is having arguments like data and next and previous, so that it is going to take the next value, and next is going to take the next value, and previous is going to take the previous value of the node. So in a doubly linked list, we have options to add or delete nodes before and after a particular node. So let's see this class called doubly linked list, which is having head initialized to none, and size is equals to 0 and tail equals to none. So size, since it's a linked list, there is no particular size for it, so we have initialized it as 0, and as we go further down the program, we'll see where we use this size for. So I have created another definition called start, which is having new data which is initialized to new node, which is initialized to the node of the new data, which means whenever a new node is being attached at the beginning, so it is going to see if the head is not none. So if it is not none, then it will add the particular new created node to the head to the top of the list. And then after creating that, the self.head will be incremented or will be rewritten as the new node, and then the size will be incremented by 1. So whenever a node is being created, whenever data is being created into the list, the size will be incremented by 1. And then for insertion in middle, we have if-else conditions. So if self.head is equals to 0, then it is going to take self.head equals to self.tail equals to new node, and then it is going to take self.head.previous as none, and tail.next is equals to none. Or else if self.head is not equals to none, then it is going to take a temporary variable called current, and it is going to be initialized to the self.head. And then to calculate the mid value of the list, it is going to divide it by 2, and then according to the middle position, it is going to create another node as a new node, and then the current will be incremented by next, and then a temporary variable will be allotted for the current dot next, and then the previous number it is going to take the previous value and the next value, and it is going to allot the slot allot the new node in between those two. And then after attaching the new node in between the nodes, then it is going to increment the size as 1. And the insertion is insertion at end. So it is going to check if the head node is none. If it is none, it is just going to return the head value as last value. Or else if it is not none, then it is going to take the last value as last dot next, and it is going to enter a new node as the last dot next. And then it will be it will take the after inserting, then the last will be it will be turned into new node dot previous, and after that it will return the value, and again it will be the size will be incremented. And then for the deletion, we again have 3 options for deletion: deletion at start, deletion at middle, and deletion at end. So for deletion at end, it is going to check if the head is none or if it is not none. So if it is none, it is going to say that the list is empty. If it is not none, then it is going to take the head value as head dot next, and head previous equals to none, and it is going to reduce the size. And if it is deletion at middle, then it is going to check again if it is none, and if it is none, then it is going to return the value as no, there is no values in the list, or else it is going to take, and again just like how we inserted values in the middle, here also we are going to use the same code, similar type of code for deletion at middle. So another temporary variable called current is going to be initialized as self.head, and it will calculate the mid value, and according to the mid value it is going to remove the particular value, and it will check the previous value and the tail value, and in between those two, if the current is being situated in between two nodes, then it is going to remove that current, and it will increment the current as none, and then it will decrease the size of the list. And deletion at end is going to check if the self.head is none. If it is none, it is going to say it is empty. Otherwise, it will go with the while loop, which is having which is going to take a variable called n and equals to n dot next, and n dot previous dot next equals to none, which means it is going to delete the previous value. It is going to check the previous value and then delete the next value which is after that previous, and it will reduce the size of the list. And for searching the node, we are going to use Boolean conditions here. So for searching the node, if the particular value is present in the node, it will say true. It will take the Boolean as true, and it will return that particular value. Otherwise, it is going to print that list is empty, or the particular node is not present in the list. And then for display, we have traversal forward direction and traversal reverse direction, which is going to print the node, the particular list in forward direction and reverse direction. So this is the driver code for it. So let's execute it. So let me give insert one. So let's insert some value at the end. Let's say 300, and again insert at front 100, and let's again see insert at middle, it is 200. Now let's display. Yeah, it has given traversal in forward direction and traversal in reverse direction, 100, 200, 300 in forward direction, and the reverse of this direction is the reverse direction, 300, 200 and 100. So now let's see the delete option. Delete at front. Let's see delete at front. Yeah, it has been deleted. And then let's see the search one. Let's search for 100, which we have deleted before. If it got deleted, then it should print node is not present in the list, since deleted friend, which we have given earlier, should be deleting 100. So if we search for 100 after deleting, then it will say node is not present in the list. Yes, it has given us the result. Now let's see deletion at the end. So let's say deletion at the end. Let's give 300. It is asking for a valid choice, since I have given 300 for delete option. Let's say delete again. Delete at middle. Delete at end. Yes. Yeah, the particular number has been deleted. Let's search for that value. If we give 300 now, it should print list is empty. Since we have given a deletion option here, it has deleted one another value, and after we have given the correct value here, it deleted again. So finally it is showing that list is empty. So if we press display, it is going to give error because we haven't given any driver code, so that if the particular a list is empty, it has to return the list is empty. So it is throwing us an error. So let's see that. Since here the last is null, so it is going to print us it is going to tell us it is going to return us error option saying that the last is referenced before assignment and the particular list is empty. So let's again run this code and see the insertion. Let's give 3 elements now. Let's give 2 elements now. 200 insert. Oh, I have given insert at front. And now let's see the display. Yeah, it has given us again. So this is how we do this program for doubly linked list in Python. So let's exit this code for now. Yes, hope you understood this program well. Thank you for watching. Have a great day.